In number 6 on the worksheet, we're given some probabilities. We're given the 50%, 20%, 30%, and then we're given some other probabilities I'll get to later. This first 50% corresponds to the probability that the car was made in Detroit. And if I want to represent Detroit with a D, again, I'm going to note down here what that D represents. The car was made in Detroit. Now that I've defined that variable, I can keep using it throughout the problem. The 20% refers to the chance that the car was made in Seattle. So I'll let S represent Seattle and again define it down here. Two T's, right? Yeah, 2 T's in Seattle. And then the 30% refers to the probability that the car was made in Los Angeles. And I'll let L be the car was made in Los Angeles. Notice that these are all simple events. The next probabilities that you're given, the next 50%, actually corresponds to a car being white, but it also has to be made in Detroit. So this is the probability So this is the probability that you have a white car given that it was made in Detroit. The next 40% is the probability that you have a white car given that it was made in Seattle, and we were told that LA produces 25% white cars. So the 25% represents the probability that it's a white car given that it was made in LA. So notice out of these probabilities, the probabilities that represent simple events are over here. These are complex events. So when you're forming your tree diagram, you want to start with the left branch being the simple events. So we're going to start with these events here and make our tree. Cut it. So now using these events, we're going to make our first branch of the tree. Oh, we finally found a marker that works. Detroit, Seattle, LA. The chance that a car is produced in Detroit is 50%. I'm going to write that as 0.5. Seattle, the chance of being made there is 0.2. And 30% chance of being made in LA. The next thing that we're concerned about is the color of the car. Right now, oh, I forgot to write, didn't I? You guys probably noticed. W is going to represent the car is white. So the next thing we're concerned about is the characteristic of the car. So the car made in Detroit is either going to be white or not. The car made in Seattle is either going to be white or not. And the car made in LA is also white or not white. The corresponding percentages are 0.5, 0.4, and then 0.6, and 0.25, 0.75. And from here we have our tree diagram, which we can now use to solve our probability problems. So now that we have our tree diagram, we're going to use it to solve the first problem, that if one car is randomly selected out of everything produced in this industry, or not industry, what are you looking at?
Don't fall, please.
I'm not going to fall. Okay, so one car is selected from this company. What is the chance that that car is white? Even though this looks like a very simple event, because the tree from left to right, the whites are on the second branch, we're going to have to understand that this is actually an or problem in disguise. So this actually means either the car was made in Detroit and is white, or the car was made in Seattle and is white, or the car was made in LA and is white. So breaking that down again, when you get or in probability, that signifies an addition problem. And now, looking at which paths represent these events, Detroit and white is here. So that's going to be 0.5 times 0.5 plus Seattle and white, so we've got 0.2 times 0.4 plus LA and white gives us 0.3 times 0.25. Adding up these probabilities, so the chance that a car is white is 40.5%. Cool. Let's try a conditional probability problem. So let's suppose we want to know that a car that is made in Seattle is white. So this would mean we know for sure that the car is made in Seattle. So that's the actual given part. We're being told we know this car is made in Seattle, and what's the chance that that car is white, given that it's made in Seattle. So when you look at this problem, over here on the tree diagram, you always read a tree from left to right. So we start here. But what happens in a given problem, we know for sure that the car was made in Seattle. So that means that we get a free jump over to Seattle. We don't have to pay attention to this probability because we know for a fact there's a 100% chance that that car was made in Seattle. So we actually start the problem here. What's the chance that that car is white? It's just 0.4. So when the tree works for you left to right in conditional probability, it's a fairly simple problem. Change that around. What's the probability that if you know a car is white, what's the probability that it was made in Seattle? So what's the chance that the car was made in Seattle given that it's a white car? Cut it while I redo the table, the tree.